Yeah, hello everyone. The last class we discussed half adder, full adder, half subtractor, full subtractor. So now we are going to design a combination logic circuit for multiplexer. First of all, what is multiplexer? How to design a multiplexer? What is the internal architecture for the multiplexer? Now we'll see. So multiplexer, it is defined as it is a combination logic circuit having more than one input. More than one input and single output. More than one input, single output. These inputs are selected by the selectional inputs. So now we'll see. It is a combinational logic circuit. Now it is also known as the MUX. MUX, okay, or it is also known as the data selector. Okay, the multiplexer is also called as MUX or data selector. Why it is called data selector? Now we'll see. Okay, it is also known as a MUX or data selector. Okay, so it is a combination logic circuit. It consists more than one input. Let it be considered 4 inputs, or now we'll see how many inputs. Single output, and these inputs are selected by the selectional input. So then how to define how many selection lines, how many input lines? Okay, here let it be considered the input selectional inputs are the n and the direct inputs are the 2 to the power of n and output is single. Okay, it is a combination logic circuits. It consists as 2 to the power of n number of input lines. So that means 2 to the power of n number of input lines, single output and n number of selection lines. It is a combination logic circuit. It consists n number of selection lines, 2 to the power of n number of input lines, single output. These 2 to the power of n number of input lines are selected by the n number of selection lines. Again I am defining. Suppose it is a combination logic circuit. It consists 4 inputs. Mean how many selection lines? 2 selection lines. That means 2 to the power of 2 means 4. So to the power of that we can define as here 2 to the power of n number of input lines, means here n indicates as number of selection lines. 2 to the power of n indicates total number of inputs. So these inputs are selected by the selectional lines. Okay. Now the size of the multiplexers. How to define the size of the multiplexer? Suppose when n is equal to 1, then size of the MUX is n is equal to 1 means 2 to the power of n by 1. The size is defined as 2 to the power of n by 1. How many selection lines? That we'll discuss. N is equal to 1 means only 1 selection lines. Then the size of the MUX means 2 to the power of 1 by 1. That means the size of the MUX is 2 by 1. Okay. When we'll give the n is equal to 2, then size of the MUX is 2 to the power of 2 into 1. So what is the number of selection line input? 2. The size of the multiplexer is 4 by 1. When n is equal to 3, the size of the multiplexer is 2 to the power of 3 by 1. That is 8 by 1. When n is equal to 4, 2 to the power of 4 by 1, then 16 by 1 MUX. So up to so and so on, when n is equal to m, then what is the size of the MUX? 2 to the power of m by n. Then we can call it as 2 to the power of n by n. Directly we can write 2 to the power of m by, the size of the MUX is 2 to the power of m by 1. So where m is number of selectional input. Okay, clear? Suppose an example, multiplexers. What is the meaning? Multiple inputs, single output. Simple. It is a combination logic circuit. It consists multiple inputs, single output. Okay, so that multiple inputs consideration, single output. Suppose you are good in movies, multiplexer theater. Multiplexer means multiple screens. We can't see in multiples in single place. So we can operate different screens. Okay, like that. Suppose example TV. Okay, so I'm giving TV example. Suppose this is a TV. Okay, what are the possible combinations, possible inputs? Inputs means number of channels. Number of channels. Okay, this is a number of channels. This is a screen. So this is the TV multiplexers. So how to select these channels? By using remote. By using remote controller, then we can select the input channels. Okay, so these are the number of channels. This is the screen, this is the remote. Okay, so these channels are selected by the remote. That's why it's called the data selector. That means we can select the input, we can select the data as the required data according to this selectional input. That's why it's called the multiplexer. That's why it's called the data selectors. Okay, clear? This is the remote, this is the number of channel, this is the screen. Okay, the remote is used to select the channel. Okay, like same, just I am consider, suppose if it is the size of the multiplexer is, how to select that inputs, that we'll see. Size of the multiplexer is 4:1, but we can consider 4:1 multiplexer. That means 4 inputs, single output. 4 inputs, so 1 input, 2, 3, 4, single output. 4:1 we can write it 2 to the power of 2/1. The 2 indicates number of selection lines. Number of selection lines. Now we'll see. So what is the size of the mux? That is a 4:1 mux. This is the output. So just I am consider these are the number of inputs. That inputs just I am consider. I want just to display the screen. I want display ECE, CSC, IT and civil. Okay, so in these are the selectional input, 2 selectional. So what are the possible combinations? 0 0 0 1 1 0 and 1 1, 1 0 and 1. So if you are press the 0 0 input, 0 0 selection line, then automatically that first line is activated. If it is given 0 0, that first line is activated. When it is given 0 0 means that output is ECE. When it is given 0 1 means that second line is outputted. Output is displayed, that is CSC. 1 0, that is IT. 1 1, that is civil. So this is the internal logic that we can connect the that 0 0 selectional input means we can select the first line. Okay, 0 1 means second line, 1 0 means third line, 1 1 means fourth line is activated at the output level. So that based on the selectional input, the selectional input is 0 0 means that first line is active. Selectional input 0 1 means second line is active. 1 0 means third line, 1 1 means fourth line. So when it is 3 selection lines, what are the possible combinations? 0 to 7, that means 0 0 0 to 1 1 1. So here 0 to 7, 8 possible combination. So that when the selectional input is 3, that combination is 0 to 7, total 8 combination. Then we'll get the 8 inputs, 0 to 7, total number of 8 inputs. When we can give this 0 0 0 means first line is active. When it is 1 1 1 means last line is active at the output level. So this is the operation for the multiplexer, internal multiplexer operation. So this is the example for multiplexer. So these are the sizes of the multiplexer. So this is the multiplexer representation. Multiplexer means it is a combination logic circuit. It consists of 2 to the power of n number of input lines, single output lines. Then 2 to the power of n number of inputs are selected by the n number of selectional inputs. The number of n number of selection lines are select the inputs. That's why it's called the data selector. The multiplexer is also known as the mux. The size of the mux is depends on the number of selectional input. When n is equal to 1, then size of the multiplexer is 2/1. When n is equal to, the size of the multiplexer is 4/1. When n is equal to 3, the size of the multiplexer is 8/1. When n is equal to 4, the size of the multiplexer is 16 by 1. When n is equal to m, the size of the multiplexer is 2 to the power of m by n. Okay, the size of the multiplexer depends on the number of selectional lines. Okay, so how to select when it is 0 0? First line is act. How? What is the internal architecture for the multiplexer? Now we'll see the 4 by 1 mux internal architecture. Suppose this is the 4 by 1 mux. 4 by 1 mux internal architecture. Internal architecture. Okay. Total how many inputs? How many selection lines? 4 inputs. How many inputs? 4 inputs. Just draw the 4 inputs. Okay, let it be considered w x y z. W x y z. Okay, next 2 inputs. 2 inputs that we can call as selection lines, that is the S1, S2 and its complement S2 complement. Okay, and here so we can give it is better to. Okay, so whether it is S1 and S2, how to select the inputs by using the selection input. S1 S2 possible combination 0 0 0 1 1 0 1 1. So when it is 0 0, first line is active, that means W X Y and Z. W is activated when S1 is 0, S2 is 0. S1 S2 0 0 0 means it's a complement inputs. So S1 is 0, S2 is 0. Okay, S1 is 0, S2 is 0, then W is activated. Okay, this is the W. Like same, S1 is 0, S2 is 0. Okay, so better to first we can draw the 2 by 1 mux, then after we go for the 4 by 1 mux. So here easily we can understand it, 2 by 1 mux. So here it is 2 by 1 mux. Only how many selection lines? Only one selection lines. Let it be considered. S is the selection lines and its complements. Okay, 2 inputs. So let it be considered inputs, that means X Y. Okay, S is the inputs. What is the possible combination? Either it is 0 or 1. So when it is 0, then X is the output. When it is 1, that is Y is the output. So according to that, X is equal 0, that is connected. X is equal 0, that is connected. Okay, when S is equal 1, then it is, that means here, so this is the multiplication of X into S bar. Here X into S1, S bar. Okay, here Y into S. These two are logic. These two are logic. So this is the single input level, 2 inputs, 1 selection line, 1 output. So that output is multiplexer output. Then it is called a X S bar plus Y S. So when S is equal 0, S is equal 0, that means X into 0 bar plus Y into 0. Y into something means 0. X into 0 bar. 0 bar means 1. X into 1. Then we'll get the X when S is equal 0. When S is equal 0, then we'll get the X. Okay. Suppose I am consider S is equal 1. X into, substitute this S value in this expression. 1 bar plus Y into 1. 1 bar means 0. X into 0 plus Y into 1. Like same, this is a 0. Then we'll get the Y when S is equal 0. S is equal 1. So this is the 2 by 1 multiplexer. Like same, we can draw the 4 by 1 multiplexer. You can draw the 4 by 1 multiplexers. How to draw the 4 by 1 mux? Okay. First selection lines. Then consider selection lines, two selection lines, let it be considered S1, S2, S1 bar, S2 bar. Okay, how many inputs? 4 inputs. We are consider 4 inputs, W, X, Y, Z, W, X, Y, Z. Okay, so here possible combinations S1, S2 selection line 0, 0, 0, 1, 1, 0 and 1, 1. So according to the 4 by 1 mux, 1 W, X, Y, Z, two selection lines S1 and S2, this is the output. Okay, when it is 0, 0, S1, S2 is 0, 0, the W is activated as output. So according to that logic, S1, S2 is 0, 0, this one is 0 for this logic gate. Okay, next one is 0, 1 case. So S1 is 0, that means with complement. So this is a without complement, one more end logic. Next 1, 0, one more end logic. Next 1, 1, that is a Z. 4 outputs are connected to the 1 OR logic. Okay, so this is the entire circuit for the 4 by 1 multiplexers. So this is the two selection lines, that is S1 and S2. So this is the single output. These are the 4 inputs. It is a combination logic circuit. It consists 2 to the power of n number of input lines, n number of selection lines and single output. So the selection lines are select the input lines or data lines. That's why it's called the data selector. This is the internal working procedure for the 4 by 1 multiplexers and 2 by 1 multiplexers. Here the expression is, you can write it here, the expression of the 4 by 1 multiplexer internal 4 by 1 mux, that is the output is equal to, what is that here initially S bar S2 bar, S1 bar S2 bar into W, W into S1 bar S2 bar plus here W into S1 bar S2 bar, here X into S1 bar S2, that means X into S1 bar S2 plus Y into 1, 0 means Y into S1 S2 bar, S1 S2 bar plus Z into S1 into S2. Substitute that values when 0, 0, then we will get 0 bar 0 bar 1, remaining all are zeros. Then the W is output across the multiplexers. This is the 4 by 1 multiplexer internal architecture.